Welcome to my projectbazaar.com. Let us discuss about the QoS-Oriented mode, spectrum and power allocation for D2D communication underlying LTE network. Let us discuss about the abstract of the product. So this paper is propose the problem of resource allocation for device-to-device communication. So that is a D2D in a third generation partnership project. So that is a 3GP and long-term evaluation, that is a LTE network. The users in the network can operate either in traditional cellular node communicating with each other. So the other via the evolved node EB, so that is a E and B, or in a D2D mode communication with each other without transferring the E and B. So in the considered model, the D2D users and cellular users share the same radio model. Particularly, each resource block, so that is a RB, within the available bandwidth can be occupied by one cellular and several D2D users. So hence the problem of interference management is crucial for effective performance of a such network. The twofold aim of the proposed algorithm is mitigate the interference cellular and D2D users, and another one is improve the overall user perceived quality of service. So that is a QoS. To control the interference for each user, we define a certain target interference levels and constrain the interference from other user to stay below this level. So the users, by minimizing the size of buffers of user equipment, so that is a UE. The performance of the algorithm has been evaluated by using the MATLAB simulation. So the algorithm shows improved performance in terms of mean packet end-to-end delay and loss of user equipment compared with the other relevant scheme. Let us discuss about the flow diagram of the product. So this is the overall flow diagram. This flow diagram, first of all, we implementing the network model, and the network model we deploy the cellular user and then deploy the D2D cellular network. So that is a device to device cellular network that is connected to the communication link between the user and the device, and then it's allocated to the channels, and then we calculate the spectrum allocation, finally calculated the bandwidth and SIR efficiency, and finally we calculate overall the performance analysis. So this is the process of flow diagram. So in the flow diagram, first of all, the network model. So in this network model, the problem of resource allocation for D2D communication is investigated for both uplink and the downlink directions. So similarly, the distribution throughput, the remainder of this paper, is applicable to either direction. Consider a basic LTE, so that is a lifetime evaluation A network, which consists of one E and B operating a fixed spectrum band spanning, and then k orbs, number of orbs is scale is equal to 1 to k. We set off all the orbs in this compression. So the available bandwidth, the described network operates slotted time basis with the time axis partition in equal to non-overlapping time intervals of the length of ts, so denoting an integer value index. So the E and B serves a n wireless user number, so that is calculated by using the, so that is connected with the communication link. So in this communication link, that is connected between the D2D cellular network and the end user. So the specific communication link, we allocate the channels. So this channel is specified to this user, so that is connected allocate of the channels, and then spectrum allocation. So in the allocate of the channels, we allocate the spectrum to the particular user. So this is the process of allocation, and then we allocate the channels, and then we efficient bandwidth and SIR will be calculated. So in the bandwidth and SIR calculated by the spectrum allocation of the process. Finally, we calculate the performance analysis. So in the performance analysis, we calculate the average number of users between the outage probability and the BER of the estimation. So in this process, we calculate by using the MATLAB software. So in the paper, the simulation process is in the OpNet. By our process, we using the MATLAB of the process. So the performance analysis by calculating the outage probability and the particular process of the process. So the network model, we deploy the D2D, so that is device to device communication cellular users by calculating. So in the D2D process, given in the figure, there are two types of D2D process will be contained. So in this process, this is the D2D communication. So the D2D communication, inbound and outbound. So these are two types of inbound and outbound process. So in this process, inbound is the underlay and overlay, and outbound control and autonomous. So in our paper, we calculating the inbound by depending on the underlay process. So underlay of LTE communication. So that is a process of D2D communication. So this is the overall process: D2 communication, inbound and outbound, underlay, overlay, and control and autonomous of the process. So here, particular interference management schemes into device to device. So the interference management scheme, that is interference avoidance, interference cancellation, and interference coordination. So this is the process of interference management in the schemes of. Yeah, so basically the overall running procedure of the flow diagram of the product. So finally calculate the D2D device of the cellular network, optimize the value of communication link. So finally calculate the performance analysis of process. So this is the overall flow diagram of the process. Yeah, let us discuss about the running procedure for the product. So click the main file and then run. So there are many outputs are displayed. So these all the outputs are related to our flow diagram. So these are the subfunction D2D communication and draw circles, the subfunction of the process. Yeah, in this first figure, so this is a base station deployment. So these are the base station. So base station deployment in the process, and in the base station deployment, deployment the cellular user. So these are the plus mark is indicate the cellular user of the process, and then device to device transmitter. So the pink color indicate the device to device transmitter. So the pink color indicate the device to device transmitter. In the sandal color is indicate the device to device receiver deployment of the process. So this is a potential D2D link. So that is a transceiver and receiver between the transmitter and receiver of the process. So that is a link between the transceiver and the receiver of the process. So in this particular potential D2D link, we calculate the spectrum allocation of the process between the transmitter and the receiver side. So we calculating the spectrum allocation between the transmitter and receiver of the device to device. In this process, the transmission probability of point of generic D2D transmitter versus the intensity of the base station. So downlink RSA and downlink and uplink PSA. So the proposed approach is indicate the blue. So base station density and the transmission probability of the D2D user of a point. So these are the process of the resource allocation of the access. So the transmission probability of the point, free channels, efficient energy propagation, and then proposed approach of the process. So transmission probability of the D2D user point, and then base station density of the process. So in this figure describes about the sensing threshold and the DPM, and then the SINR outage probability of the ODD2D. So device to device process, the transmission probability of the point, downlink RCA and then the uplink RCA, and then calculating with the proposed approach. So the transmission probability, that is resource allocation of the process, and then blue is indicate, the pink is indicate the proposed approach of the process. So the SINR outage probability, so that is signal to noise ratio of the process. So device to device communications of the OD process of the sensing threshold in the decibel by mm of the process. So in this next figure, the SINR outage probability OD of D2D transmission versus the number of available channels. So the number of available channel interference of the clustering of the process. So up to 40, the SINR outage probability of the D2D device. So same procedure following the downlink and uplink of the resource allocation of the process, and then the proposed approach by calculating the number of available channel versus the SINR outage probability. Finally, in this figure, the overall outage probability of the process. So the D2D transmit power and then average outage power to user by calculating the downlink and uplink of the proposed approach. So these are the overall running procedure for the product. Thank you for listening this video.